What is dark matter?
Dark matter is a type of matter in astronomy, hypothesized to account for mass that cannot be seen. Dark matter emits no light and cannot be seen.
Theory. Scientists cannot agree about what dark matter exactly is. Some scientists believe that dark matter consists of extremely massive objects that drift through space. Such objects could include black holes, dense dwarf stars, and neutron stars. Collectively, these objects are known as massive compact halo objects. Still, other scientists disagree with these ideas and propose that dark matter is made up of clumps of smaller objects that do not interact with electromagnetic radiation.
This will make these objects extremely hard to see, if not invisible. These scientists call these objects weakly interacting massive particles.
At the moment, it is not possible to assert which of these two theories is correct, as scientists do not have sufficient evidence to prove or disprove either one. However, some scientists are striving to further advances in this field. Fritz Zwicky was the one who proposed this idea.
He, along with German scientist Walter Bethe, proposed the existence of dark matter and correctly hypothesized the existence of neutron stars and supernovas. These discoveries will help future scientists and cosmologists estimate the true size and age of the universe itself. It is worth mentioning that his ideas were first dismissed for being much too eccentric, but they are now regarded as important concepts of modern science.
Other key figures in this field include Vera Rubin. She asserted that when galaxies rotated faster than the mass of their visible matter could account for, rings of dark matter were acting upon them. She proposed this concept in the mid-70s, and many modern scientists agree with her ideas. Unsolved mysteries.
Scientists have asserted that visible matter only accounts for 0.5 or 5% of the universe's total mass. Those who support the existence of dark matter estimate that this substance makes up for 20 to 30% of the universe's mass, but it fails to account for the remaining mass. Scientists believe that a force called dark energy fills this void, meaning that the missing mass is accounted for not by matter, but by energy.
While this may be a concept difficult to grasp by most people, the relationship between mass and energy has been successfully described by Albert Einstein using his famous theory of relativity, or E equals mc squared. This mass-energy equivalence is the concept that the mass of an object or a system is a measure of its energy content.
The idea of dark energy not only explains the phenomenon of missing mass, but also the rapid acceleration of universe expansion. The problem was posed by two independent experiments that were conducted in the later half of the 20th century. In 1998, these non-affiliated teams of astronomers determined that the universe is expanding at an inconceivable rate.
American cosmologist Michael Turner coined the phrase dark energy while attempting to explain that this phenomenon was attributed to a mysterious repulsive force that acted upon the entire universe. Evidence has slowly started to accumulate since the later half of the 20th century, and some scholars even believe that Einstein predicted the existence of dark energy during the early 1990s. You may be wondering how this idea is put in practice today.
Because dark matter does not interact with electromagnetic radiation, observing it directly is impossible. Astronomers look at the stars to find evidence of the effect of dark matter on gravitational fields.
Also, scientists are working to detect dark matter in a more direct fashion. Assuming that it does exist, dark matter should be all around us. Therefore, it should make up a small part of the Earth's bombardment of particles and waves from outer space. Unfortunately for cosmologists, detecting dark matter and distinguishing it from cosmic noise is impossible. This is why astrophysicists often test for dark matter deep underground so that no cosmic radiation interferes with their studies.
An example of such a study involves germanium, which is an element used in transistors. Researchers believe that particles of dark matter, called weakly interacting massive particles, will collide with germanium atoms in the formation, causing tiny electric currents and detectable changes in temperature. Another test involves the placement of light sensors inside holes that are drilled more than 1 kilometer into the Arctic ice.
Scientists conduct these experiments because it is believed that neutrinos, which are tiny particles thought to be produced by dark matter, give off muons, or glowing blue particles, when they collide with the freezing ice. Finally, the underground Large Hadron Collider in Switzerland is capable of causing collisions that attempt to recreate those that happened during the Big Bang. Particles of dark matter are hoped to be tested using this piece of technology.